Good morning, gentlemen. Today we will start to explain how to analyze the vibration. After measuring the vibration by the data collector and the analyzer, and after transfer the data to the software on the laptop, our vibrations analysis depending on vibration spectrum, vibration time of form, and sometimes we need to measure the phase. We will classify the vibration spectrum to three categories. Number one, subsynchronous problem. Number two, synchronous problem. Number three, non-synchronous problem. What is the difference between the subsynchronous and synchronous and non-synchronous? Do you remember when we explained before the vibration spectrum for y-axis uh, amplitude may be displacement, velocity, acceleration, and the frequency for the x-axis may be hertz, cycle per second, or cycle per minute, or order. Order, it will be related to the running speed of the machine. What does it mean? It means when the machine running at 3000 RPM, 3000 RPM, it means equal 1x or 1 RPM. Then, when the machine peaks for the vibrations peak appear at to 6000 cycles per minute, it is mean 2x or 2 RPM. 9000, it means 3x or 3 RPM, and so on. Thus, we will start to classify the vibration to three categories. We will start to classify the vibrations to three categories are as follows. Number one, the causes of subsynchronous component in the spectrum. Frequency below speed, its mean less than 1 RPM. Number one, hydraulic instability, oil whirl and oil well. This phenomena happen only on fluid film bearing. Never say happen in the anti-friction bearing. And the most common peaks appear at frequency less than 1 RPM from zero point 0.4 to zero point 0.5 from 1 RPM. That's the oil whirl and oil well. And RAP, the cage frequency of anti-friction bearing. For anti-friction bearing, the frequency depending on four frequency: cage frequency, and the ball spin frequency, and inner race frequency, and the outer race frequency. Only the cage appear at subsynchronous problem. Looseness or loose anti-friction bearing in its housing, and always appear at 0.5 from the RPM, half of the RPM. And the surge in centrifugal compressor and excessive clearance between impeller and the casing, its recirculation, and always appear at zero point 0.3 to zero point 0.4 from RPM. Look, this is the spectrum. This is actually case study from our software, because our course analysis will depending on practical or actual from my laptop, because I have more than 3000 rotating equipment, have included all the vibrations brought. Look, for example, this is air cooler 1501. We measure the vibration at M1H. What does it mean by M1H? I explained it before. It means the outboard bearing in the horizontal direction. Look, this is vibrations appear at 1 RPM, but actually there are another peak here, very small peak. Thus, I will start from the software, make expand. Look, to amplify the peak. The peak started to appear at 0.5 from RPM. It's 100%, my friend, mechanical lossless between bearing and its housing for non-drive end bearing for the electrical motor. Okay, look, this is another case study for the pump. This is another case study of the pump. When we will start to look the spectrum, I will start to see, look, 1 RPM, 2 RPM, 3 RPM, and 4 RPM, and so on. I will say, this is, my friend, maybe misaligned, maybe structure lossless, but actually, look for this is a small peak. This is a small peak, less than 1 RPM. I will start to make expand. Look, this is the expand. It started to appear at 0.5, half RPM. This is 100% for the pump bearing loose in its housing, not mechanical looseness for the structures. You understand? Okay. Number 2, the causes of the vibration at synchronous component in the spectrum. What does it mean? It means the frequency equal n RPM, where n is integer number. It is mean 1 RPM, 2 RPM, 3 RPM, and 4 RPM, and so on. What is the problem? Unbalance. Pitch line run out. When you practice eccentricity, this phenomena or this is case happens between 2 parties fitting together, but the 2 center line are not coincident. Like bearing on the shaft, like gear on the shaft, like pulley in the shaft, like the gap between the rotor and the stator for the electrical motor. If the 2 center lines are not coincident, the vibrations will appear at 1 RPM, and the imbalance will appear at 1 RPM, and the misalignment appear at 1 and sometimes 1 and 2 and 3 RPM. Bent shaft appear at 1 and a little bit 2 RPM. Looseness, this is looseness, very complicated, and I will explain it in detail. And soft foot always appear at 1 RPM and 2 inline frequency. And the coupling effect and a blade or vane passing frequency, it is equal number of blade by the RPM. Reciprocating motion for the reciprocating pump and reciprocating compressor 1 and 2 and 3 and 4 and 5 according to the number of the reciprocating motion. Gears, if we have a gear, there are another frequency equal gear meshing frequency equal the number of the gear by RPM. And the blade passing frequency for the compressor or turbine equal the number of the blade by RPM. And the slot frequency of the electrical motor equal number of slots by RPM. This is a synchronous problem. Look for this case study. This is practical from our software. Look, this is a problem. Vibration spectrum 1 RPM, 2 RPM, and 3 RPM, and 4 RPM, and so on and so on and so on. This is 100% mechanical lossless. Do you understand? Look, this is another. Appear at 1 RPM. We can say soft foot. We can say unbalance. We can say mechanical lossless. And I will explain for you how to distinguish between the unbalance and eccentricity and bent shaft and misalignment. Okay? Look, this is for another spectrum. Appear at 1 and 2 and 3 and 4. And when the peak appear at 2, more than 1 RPM and less and more than 2 and 3 and 4, this is 100% mechanical lossless and misalignment and coupling defect. And the coupling defect. Number 3, the causes of non-synchronous component in the spectrum, frequencies above but not integer number. Tuning speed, frequency by RPM, but the frequency more than 1 and not an integer number. What does it mean? It means if the running speed equals 3000 RPM, 1x, the vibrations will appear at 1.2, 2.4, 3.2, and so on. What is the problem? Anti-friction bearing problem. System resonance. electrical problem, and other causes. Look, this is 100% case study for the gearbox for slide vane compressors, and this is spectrum for the gearbox. Look for this peak appear at 3.2 and 6.4 and 9.6 and so on. You understand? When we capture this spectrum, 100%, this is anti-friction bearing defect. You understand? This is introduction, and tomorrow, inshallah, we will explain one by one how to detect or analysis for the vibration for imbalance, misalignment, bent shaft, eccentricity, and soft foot, and so on and so on. This is the quiz. 3 questions. You have to solve it in 1 minute. Choose the right answer. The anti-friction bearing problem happen at subsynchronous, synchronous, and non-synchronous. The mechanical looseness between bearing and housing problem, subsynchronous or synchronous or non-synchronous. The bent shaft problem, synchronous or subsynchronous or non-synchronous. Thank you, and tomorrow, inshallah, we will complete. Thank you.